Good job. Law of inertia, force equals mass times acceleration, action, reaction. Good job. He did change our understanding of the world forever. Good job. All right, so these are some great answers. So we do have an idea of who Isaac Newton already is. Today we're going to talk about his universal law of gravitation along with circular motion. Okay, so circular motion is any motion that moves in a circular path. And these are just some examples of circular motion. Yes, with enough force, this is possible. Don't try this at home. So that's also circular motion. Again, you have to give enough force. And this also deals with momentum, but we're not going to focus on momentum. Okay, so centripetal force is the reason why all of those people did not fall to their deaths. It's any force that causes an object to go in a circular path, and it always acts in the direction towards the center of the circle. So the force is pulling it inward. So normally objects travel in a straight path. They always want to travel in a straight path. But since we're pulling them inward, that's going to cause it to turn into a circle, to travel into a circle. So again, that inward force is called centripetal force. All right, so I just told you what it is. Go ahead and answer me the first question, and then take a guess at what the types of centripetal force can be. All right, so good job. I got a couple of 100s. I don't know what that is. So the centripetal force, again, it's an inward force. It goes towards the center of the circle. And these are our types of centripetal force. We have gravitational, friction, tension. All of these are going to cause objects to move in a circle, in a circular path. I want to talk about centrifugal force and how it does not exist. It's not real. This is a made-up force. It does not exist. So have you ever ridden on that ride, the Gravitron? It's that ride that spins around and around, and then you can get up on the side of the wall and it's pushing you against the wall. Well, if you haven't ridden that ride, think of any other roller coaster ride that spins. If you're sitting in a seat, you're pushing your way towards the person on the outer side. You're pushing your way outside of the spinning circle. So it was said that there was a force pushing you out, and they once called it centrifugal force. Oh, I can't even say that word, centrifugal force. But as Newton and as other scientists have discovered, that force doesn't exist. The only reason why you feel like you're being pushed out is because of inertia. Remember, objects in motion stay in motion? Well, that spinning is a motion. If that spinning is causing you to feel like you are being pushed outward, but you're really not. Again, there is no centrifugal force. There's no outward force. All right, so let's take another quiz. Again, recall Newton's first law, an object in motion stays in motion. If the centripetal force of an object moving in a circle breaks, which path would the object take? So which way do you think the object's gonna go? A, it's gonna continue in a circle. B, it's gonna go outward. Or C, it's gonna travel horizontal.
B.
Oh, you take a vote on your Nearpod.
Crap.
But thank you. All right, so only 2 people got this answer right. So because of inertia, if the string was released, the ball would continue to move in a perpendicular to the center straight line. So it would continue to move perpendicular. So let's go back and look at that picture. It wouldn't continue to move in a circle, because the centripetal force broke. So nothing's pulling it to the inside. For B, remember I said there's no centrifugal force? So it wouldn't continue to go outward, out of the circle. It doesn't work like that. There is no force like B. It's going to continue moving C, and I'm going to explain why. Right here. So because of centripetal force, again, an object will always have a constant velocity perpendicular to the center, and it will always travel in a straight line. So if there was no centripetal force pulling it towards the center, objects would continue to travel in a straight line. But since we're pulling them in, they're going inward. So the velocity is always going to be perpendicular to the center. That's how it's always going to travel. And y'all can't see what I'm seeing because I paused it. So again, it's always going to be perpendicular to the center. That is the velocity it's going to be moving. So keep in mind that revolving objects have a uniform motion, a constant speed. Their speed's not changing. It's always going to be the same speed, but they are constantly changing direction. So since they're always changing their direction, we do say that it's accelerating. We say that it has a centripetal acceleration. Again, this is like if you're doing donuts in the parking lot, which is illegal, don't do that. But if you're going the same speed in a circle, yes, your speed isn't changing, but your direction is. So therefore you are technically accelerating because you're changing direction. All right, what is the natural direction any moving object will want to follow? Again, this relates to Newton's first law. So what is the natural direction? Did I not put an answer on this one? I don't know why it's not popping up. Oops.
Yeah, you put an answer to it.
I did? Okay, well, I don't know why mine's isn't popping up, but I will tell you the answer in a minute. Oh, okay. Well, there you go. It shows you the answer. It's a straight path. Remember, objects always want to go straight. They're lazy. They don't want to change anything. An object in motion is going to stay in motion, and it's going to stay in a straight path. Again, the only reason why an object is traveling in a circle is because of that centripetal force that's pulling it in to travel as a circle.
You could say objects, the answer was pretty straightforward.
I like that pun. That was a good pun. All right, so let's recall Newton's 3 laws of motion. Let's see if you can match them up correctly. Good job. I'm seeing some 100s. Y'all are doing great. We do remember Newton's laws. The test was yesterday. How did it go? How'd y'all feel? How many of y'all haven't even taken it yet?
I was expecting to see my results as soon as I finished, but then I find myself that you would have to do it. So I had a major anxiety attack because I was so nervous for that test.
I was
Oh, I'm
nervous
so
too.
sorry.
I didn't
I'll
know
probably
what I
have it
got.
finished graded by tomorrow.
Oh no, it's fine. Don't worry.
Sorry. I'm sure you did fine. I'm sure it was an easy test. So good job to everyone who got 100. An object in motion stays in motion. An object at rest stays at rest. That's the first law of inertia. That's the laziness. Remember, all objects want to be lazy. They don't want to change. The second law calculates force. The force of an object is equal to mass times acceleration. And then the third law is the law of action and reaction. For every action, there's an equal and opposite reaction. Remember, there's an equal and opposite force. And with Newton's third law, this is what he used to talk about universal gravitation. So the law of universal gravitation between objects states that every object in the universe attracts every other object with a force. What that means is the sun's attracting Earth, the Earth's attracting the sun. The moon's attracting Earth, Earth's attracting the moon. Saturn is attracting Earth, Earth is attracting Saturn. Our Milky Way galaxy is attracting another galaxy, and that galaxy is attracting us. So everything is in relation to each other, and everything is attracting each other in some way. So again, gravitational force is always going to be attractive. It's not pulling anything away, it's pulling objects in towards themselves. And that's why we rotate around the sun, because the sun is pulling us in. That's why the moon rotates around Earth, because the Earth is pulling the moon in. Remember, forces are always equal, but accelerations are not. Acceleration is going to change depending on the mass of the object. So the larger mass won't feel the acceleration as much as the smaller mass will. So for Earth, we don't feel the moon pulling us, but the moon does feel the Earth pulling it. That's why the moon rotates around the Earth. But compared to the sun, the Earth is a lot smaller than the sun. So the sun doesn't feel the Earth pulling it, but the Earth does feel the sun pulling it. That's why we rotate around the sun. Again, every object in the universe attracts every other object. Even every particle in the universe exerts an attractive force on every other particle. So everything attracts everything. That's just the law. And nothing we know can block gravity. Nothing that's been tested that we know of can block gravity. Of course, in years to come, we might have a scientist who can discover something. But as of right now, nothing can block these pulls.
Literally,
All right, so I
the
just told you this
next day on
answer.
the news, a scientist discovers a way to ignore gravity and invented an anti-gravity device.
That would be pretty cool. That means we could be like floating on Earth. Just kidding, that would be too scary. What if we float too high? Never mind. All right, so is gravity an attractive force or a repulsive force? All right, I'm seeing all correct answers. Good job. No one's guessed the wrong answer yet. Yes, gravity is an attractive force. All objects in the universe are attracting other objects. They're pulling it in. So gravitational force is a pull. It's not a push. We're not pushing things away. We're pulling things in. So again, this does relate to Newton's third law. For every action, there's an equal and opposite reaction. Again, for every force acting on an object, there's an equal and opposite force. So it's important to note that Newton did not discover gravity, but he did discover that gravity is universal. Everything pulls on everything in a beautiful, simple way that involves only mass and distance. And then he came up with this law. This is the law of universal gravitation. This is the formula. This year, since you are not in school and you cannot use a calculator with 10 to the 20th power functions, we won't be plugging in numbers like we normally would, but we are still going to talk about the effects of this law. So in this law, Newton stated that the force for any two objects is directly proportional to the mass. What that means is if the mass of one of the objects increases, then the gravitational force will also increase. So the bigger the mass, the bigger the force. The smaller the mass, the smaller the force. So if you have the Earth and the moon, that force is going to be a lot smaller than the Earth and the sun. The Earth and the sun are going to have a greater force than the Earth and the moon. All right. The other part of his law stated that distance affects force. He deduced that force decreases as the square of the distance between the objects increase. Meaning if objects are spread apart, the force of gravity will decrease. If objects are brought closer, the gravity will increase. So the less distance something has, oh, did I do that backwards? No, the less distance something has, the greater the force. The more distance apart objects are, the lesser the force. So if you are far and spread out from another planet, you're going to have less force acting on you. That's why we don't feel the pull from all the other planets and all the other galaxies, because they're way too far to feel that force. But since we're closer to the moon, we can feel that pull. That's why on full moon days, if you've ever been to the ocean on a full moon, the waves are crazy. The waves are so big. The tidal waves are crazy. Surfers love to go surfing on a full moon because the moon is pulling those waves with a greater force. All right, so now we're going to play a game to see what you remember. Do y'all want animals, space, or underwater?
Space.
Underwater.
I heard space
Like
first, so I'm
space.
picking space. All right. Again, your names are hidden, so don't worry if you get the answers wrong. I do just want you to try. They're so cute, right? What is this blue thing? I tried to figure it out yesterday. What is this blue thing? What about the green
It's an
thing?
alien.
An alien.
Looks like a blue koala.
It's a man who's been deep freezed for. It's a man who got stuck in a freezer for too long.
All right, are y'all ready? According to Newton's law of universal gravitation, what will happen to the force if the mass of one or both objects increase? So if mass increases, what happens to force? Good job, Turtle. According to Newton's, oh, just kidding. Yes, so if mass goes up, force goes up. Okay, so what will happen to the force if the distance between objects increases? So if the distance increases, what happens to force? Hopefully it was the right one. Good job. Good job, Turtle. So if distance increases, force decreases. All right, two objects with the same mass are 1 meters apart. If the object's mass is doubled, what will happen to the force? So if you double mass, what happens to force? Good job, Turtle, again. The force will double. If mass doubles, the force doubles. All right, so now, sorry? So now if the distance increases 5 times farther, what will happen to the gravitational force? Pay attention to that formula. Pay attention to what happens to distance in that formula. Since distance is squared, it would be 25 times weaker. Good job, my turtle, whoever you are. All right, so that's all I wanted to talk about today. Tomorrow we'll get into the math calculations. Go ahead and do your practice assignment and let me know if you have any questions. If you haven't taken your test, make sure you finish all your work and get your test done.